Biomedical Glassware by Andrick and Dallas. So, who does this problem affect? For one, it affects healthcare workers and first responders. It is a limited time delayed diagnostics. It affects students and schools due to nurses' lack of fast, non-invasive health checkups. And where the problem occurs is hospitals and clinics, schools, workplaces, and manufacturing plants, and public spaces during health crises. Why does this problem matter? Well, for the school impact, school nurses can quickly check overall student health, fast, being faster, with faster responses to illnesses without invasive tools. Why does this why does this matter? Indoor and outdoor activities. So monitoring vitals during exercise or physical labor, such as moving heavy objects, supports safer outdoor and industrial work environments. So, with some previous solutions, to improve our design, we analyze existing patents related to AI smart glasses. These patents help identify what was already being used, what was already existed, and what kind of gaps remain that we were looking to fill. Our goal is to build on proven ideas while improving medical usability. And down here you can see we got our patents through USPTO. Patent 2. So this patent describes a low power AR/VR headset for general use. This is kind of what we want to do, except for a more specific use. Patent 4. The image isn't loading. But basically, what this patent did show is the use of transparent AR and VR technology with micro displays, which is kind of what we want to have. We want to have displays that show what the user's vitals are, or what the user can see of the person's vitals. And some takeaway from patents. Existing patents focus on AR and VR or task management, not healthcare, which is what we want to focus on. Medical application requires accurate biometric sensing, being lightweight, non-bulky design, integrated AI analysis, and the fact that our project specifically addresses these gaps. Safety, ethics, and operating environments. So for safety and legal ethics, HIPAA compliant data handling is something we need, along with protection against biometric and data misuse, and medical grade accuracy to prevent misdiagnosis. When it comes to ergonomics, we need comfortable for extended wear, minimal user interface interaction, and usable for all age groups. And for operating environments, we need this would be things like hospitals, schools, airports, factories, homes, and needs to be resistant to sweat, humidity, dust, and temperature variations, because these could all be things that the user might experience while wearing these glasses. Prioritize design requirements. Medium priority, which are cost efficiency, the durability, and the ability to sanitize the design, and the 3 to 5 year product life via software updates. So some expert validations. We have a couple people. We have Javier, the dean of UT Tyler College of Engineering; Julie DeLello, professor of education at UT Tyler; and Blaine Pace, an adjunct lecturer of computer science at UT Tyler. Some concept surveys. So this is one of the concepts we came up with, and on here on the right side you can kind of see the survey that we got through POTW and us just filling that out. So data driven selection, which is our decision matrix. You can kind of see what points we wanted to hit on the most. So one, is this doable or not? Two, is it aesthetically pleasing? Is it what we want it to look like? And three, is it comfortable to use? And these are the three specifications we chose to prioritize. As you can see here, here's one of our sketches, our early sketches of what we thought this would look like. And down here you can see the totals of what everything got. And as you can see, the yellow, or the colors, are the different designs, with the yellow obviously being the highest graded one. So environmental and ethical considerations. For the environment impacts. Current risk are things such as identified that current Meta AI glasses rely on rare earth minerals and expensive lithium-ion batteries. The sustainability strategy, we propose using high quality, durable, and recyclable materials to extend the product life cycle. And comparisons modeled the shift towards premium materials after industrial leaders like Apple to improve overall product sustainability despite higher initial pricing or cost. Ethical justification. The project is ethically viable because the benefits, speeding up nursing workflows and enabling early disease diagnosis, outweigh potential risk. And also, the design prioritizes HIPAA-approved materials to ensure patient data privacy is maintained through the device's life. Testing benchmark and data requirements. So for the performance benchmark, we first had the battery endurance. The internal battery must sustain continuous video recording for at least 30 minutes. Thermal accuracy, we want the sensors to detect surface temperature within a range of -40 Fahrenheit to 750 Fahrenheit with a 2% degree accuracy. Voice recognition, the AI assistant must correctly interpret commands in a 70 decibel environment with a give or take 5% accuracy. Biometrics tracking, the heart rate sensor must track BPM during high intensity intervals, such as HIIT exercises, with a degree accuracy within a give or take 3 BPM. And for data requirements, quantitative, total running time in minutes, recorded temperature output, and percentage of correctly executed voice commands. And qualitative is the pass or fail assessment for broader resistant seals. Expert consultation. So here we have one from Javier Kipros. He noted that the plan seemed reasonable, but we should check for grammars and spelling to have a more formal language in our presentation. We should consider using images or infographics to illustrate the narrative of our slides, and if we have not previously done so, it may help that to provide some more information about the meta tools that we are employing. Testing results and analysis. So some results we got is that the prototype performed consistently across multiple trials. The design requirements were pretty much all met on the collected data, and minor variations in results were observed but remained within acceptable limits. So for data analysis, we analyzed that the data collected was accurate and repeated due to consistent testing. Graphs and tables were used to clearly display trends and outcomes, and the limitations of the tests were identified and considered when analyzing results. Implications. So first, the testing data showed that the prototype is functional but has areas for improvement. And second, results provided clear direction for potential refinements.